So we got our two kind of, again, basic collinear Newton's second law questions here. All right, first one is a wagon that's accelerating at 3.1 meters per second forward. We have friction acting with a force of 87.5 newtons. What do we have to know about friction? What does it always do? Yeah, it always opposes or goes against. Okay, so it's going to be a backwards force. The mass of the wagon is 32.2 kilograms. We're looking for the magnitude and direction of the pulling force. All right, so our free body diagram should look something like this. All right, we got 32.2 kilograms worth of mass in the wagon. We have an unknown applied force pulling forwards. We have a known force of friction pulling backwards. Okay. And then we also know the acceleration is 3.1 meters per second squared in a forward direction. All right, so you can give them 1 mark for givens. Okay, what can I calculate right now since I have mass and acceleration? F net. Okay, so that's the first thing I want to do. All right, I want to calculate F net using the only way available to me right now, which is mass times acceleration. So that's going to be 32.2 times 3.1. Okay, so we're looking at 99.82 newtons. And that's going to be forward. Okay, that's our net force. It is not this force. All right, I'm going to use it to get that force. So give them a mark for the F net being mass times acceleration. Okay, the work there. And we'll just say that's good for there. So we're up to 2 marks here. Then the other way to calculate net force is through the vector sum of all forces. So that would be the force applied plus the force of friction, right? Give them a mark if they have that written somewhere. I'm going to manipulate this to find the applied force. So the applied force will equal F net minus the force of friction, which will be 99.82 minus negative 87.5. That is crucial that they have that. So give them a mark if they have that step there. Okay, so we're subtracting negative 87.5, and we're getting that the force forwards is 187.32 newtons. Okay, but we only have 2 significant figures, so we are going to round this to 1.9 times 10 to the 2 newtons forward. Okay, they must have the direction on there to get it right. If they don't have the direction, it's wrong. Not half off, wrong. Okay. All right, so that one's out of 5. Questions on that one? I didn't add it, I subtracted it. No. If I'm going to pull forward, Tanner, okay, if I'm going to make this thing accelerate forwards, I need to pull with that much plus this, right? This is the net force here, the 99.82, right? It's the difference between this and this. So FA has to be much, much bigger than this one. With me there? Okay. All right. Any other questions on number 1? It's out of 5, yeah. Okay. And then we have an elevator question. And I warned you about this one yesterday. It's like C on number 13 from the worksheet from yesterday. Okay, it is moving at a constant speed. What does that mean? F net is 0. That is the most important thing that we have to realize in this question, is that the net force in this question is 0. All right, so we have an 1100 kilogram elevator. It is being pulled upwards with some unknown tension and being pulled downwards by a force of gravity, which will be calculated 1100 times 9.81 is 10,791 newtons. Okay, 1 mark there. And, sorry, 1 mark for calculating the force of gravity. Okay. Now, F net equals tension plus the force of gravity. Everybody all right with that? And we know that F net is 0. Okay, so let's say we'll give them a mark for this, and then we'll give them a mark for saying that F net minus the force of gravity equals T, which will be 0 minus negative 10,791, okay, which makes T 10,791. How many significant figures do I have here? 4. Did I ever use the 4 meters per second for anything? That's a rotten, dirty, dirty trick. And I'm all about rotten, dirty tricks. So get used to it. You never use the 4. It's not part of your calculations. So you will have 1.079 times 10 to the 4 newtons up. Or I would accept positive as well. Okay. So 1 mark for, sorry, that's too many. Okay, so 1 mark for the free body diagram, 1 mark for calculating the force of gravity, 1 mark for sum of all forces, 1 mark for the answer, 1.079 times 10 to the 4 newtons up. Okay, it's out of 9. Give them a mark out of 9, and then you can hand them in to me up here, please.